Welcome to my talk, Guide to Reactive for Spring MVC. First of all, a couple of words about this session. I decided to make this talk for Spring MVC specifically because that's where the majority of applications are today. And I want to give a heads up that this is a somewhat introductory talk. The idea is to kind of break the ice, with Reactive and try to make it understandable in a way that you can apply it in existing applications, and also to learn a little bit about it, to get a little bit of exposure from a practical perspective, which doesn't expect you to make big changes that you might not be ready for. So if you have quite a bit of experience with Reactive, or if you've been doing stuff with it already, you might find this session to be a little bit below your level, so just keep that in mind as we begin. A couple of words about me. I'm a committer on the Spring Framework team. I've been on the team for about 6-7 years now, Spring engineering. Before that, I did training and consulting for Spring applications. And even before that, I did lots of different enterprise application development in various domains. So I've been around Java and Java development for quite a bit of time. Right. So when we've had lots of Reactive talks in the past, more than a couple of years here at Spring One and in other conferences. And even at this conference, you will find that the majority of the talks are going to focus on using a full Reactive stack. And this is completely understandable because that's where you get the most benefits of the non-blocking concurrency approach. But at the same time, this is not necessarily something that everybody is ready for. So here's, for example, a full Reactive stack that we have with Spring WebFlux, where you can run completely asynchronous foundation using non-blocking I/O, which is a fundamentally different way of processing and dealing with requests and responses versus the more traditional Servlet container assigns a thread for a particular request and then do the processing for that, and then you can block that thread as you want to. Here we're talking about a kind of a more non-blocking approach, which means that we're using a very small number of threads, and then as we process the request and response, if there is a slowdown, then we might basically pick up later. So there's a lot more switching of threads. But ultimately, the benefits of that concurrency model is that it's more efficient, it's more scalable under load, and that makes it also more resilient. But the question really here is, how can we use this in order to add value to existing applications? I keep thinking that's my microphone, and that's not my microphone. So how can we add value to existing applications? That's the big questions here. And the reason why this is a kind of a useful approach or a useful perspective in my mind is because it's less risk. You don't have to switch to a whole new stack. You can get practical hands-on experience with Reactive programming. You can get exposed to what does it mean to actually work with Reactive libraries. And I'm going to show you some stuff which hopefully will have some immediate benefits for what the kinds of things that you do in your applications. So in Spring MVC, of course, Spring MVC was built for the Servlet API and for Servlet containers. It was built for the original version of the Servlet API. In modern times, the Servlet API has a non-blocking I/O option, but this is not something that you can introduce into an existing ecosystem of frameworks like Spring MVC and others like Timeleaf and many others in the ecosystem without changing fundamentally the contracts underneath in the framework itself. The assumption is for blocking I/O that when we do a read or a write to the request or response, we're going to wait until that write is complete, and then we're going to continue. Those kinds of assumptions are very difficult to break without changing the contracts and the foundations of a framework. So that goes very, very deep to make that sort of change. But in Spring MVC for quite a while now, many of you will know this, is that we've had support for asynchronous request processing. This came with Servlet 3.0 and Spring Framework 3.2. So it's been around for 3 generations already, and it's used very widely to decouple the processing of the request from the servlet container thread. That's the thread per request model, which we had originally. And for example, in Spring MVC, you can return a deferred result. You can also return callable, and there's others like SSE emitter. And that basically allows you to let the servlet container thread go. We exit all the way from that thread, and then we can continue doing something in the background while the response remains open. And then when we're done with whatever it is, maybe we're waiting for an event, maybe we're computing something, maybe we're making a remote call. When that something completes, then we can actually write to the response. And at that point, it's still a blocking write, but the actual handling of the request can be decoupled from the servlet container thread. And we can use that same foundation for us to be able to handle the request reactively. And we'll see what that means, but essentially we're talking about using reactive libraries in order to do some sort of handling and then return back to the controller. So the first thing I want to talk about is a reactive client for HTTP, making HTTP requests. How many of you here have used the RestTemplate? Everybody, yes. So RestTemplate, we've had it for a very long time. It was created 10 years ago for Java 1.5, and it's very widely used for making HTTP calls. It's a simple API based on template methods. So you get a sort of a one-liner to make a call, these kind of recipes for making HTTP GET, HTTP POST. Originally, there were 24 methods in that API, and this was designed for Java 1.5, so that was the sort of state-of-the-art at the time. Today, those methods have gone to 40 plus. So the experience that we had over time with the RestTemplate was that at some point, we started to have too many variations of these methods, and the whole template method approach begins to become a little bit cumbersome. You go into the IDE and you do a control space, and then you see a ton of methods. And over the years, there's been a number of times when we chose not to add methods for things that are less common. So for example, if you want to do an HTTP delete with a body, I don't think we have a method for that specifically to make that easy in the RestTemplate. You have to go to one of the exchange or execute methods, which are a little bit more general. So we try to hold back. They could have been more than 40 today. So that's kind of one limitation that we ran into over time with the API. Of course, it was designed and built as a synchronous blocking API from the start, which was okay 10 years ago because the idea was that you use the RestTemplate in a client. And in a client, if you make these kinds of calls, it's not a problem to block because we're talking about a single thread anyway. And it wasn't very common to do a very high concurrency type scenarios. There's also no streaming. I say no streaming. It's possible to do streaming with the RestTemplate in one direction, but not both. But it's not easy, and it's pretty low level. You're basically streaming the bytes. It's not something that it was built for originally. So fast forward 10 years, and let's see what's actually happened during those 10 years and why the RestTemplate looks a little bit dated by now. Well, first we have Java 8, and just like Java 5 brought new features like annotations, Java 8 brought lambdas and new options to design APIs in a more functional style, in a more functional way. So that's one big difference is today when we take a look at redesigning what should a REST client be, it's a very different context. Moore's law is no more. Well, we know that, right? The speed at which the hardware continues to get faster and faster stopped some time ago, or is not. We're not getting a free lunch from the hardware anymore. But at the same time, the applications are becoming handling bigger loads, and they have to do more asynchronous things on the server side, or rather things that require I/O and waiting. Really, with the REST template or anything of that nature, which is going to make a remote call, we're pretending that it's synchronous, because that's the simplest API that we can use. But of course, network operations are not synchronous, and we're only pretending like they are. And in many cases, we can no longer pretend that those operations are synchronous, because that has a cost and a price associated with it. And it takes more resources, and it takes more time, and it's difficult to orchestrate a number of different calls and to do that efficiently. So we have the WebClient, which came in Spring Framework 5, and that has a functional, fluent API. We took a different approach versus the REST template, where we did not want to be in that same position where somebody is asking for HTTP delete with a body, and we have to say no because it's way too many methods that we already have. We did not want to be in that situation. So it's designed with a more functional, fluent style API. I'm going to show you something in a little bit. In a moment. It's asynchronous and non-blocking from the foundation, from the start, which means out of the box, it is asynchronous and non-blocking. And you have to do something extra in order to block and wait for the result. So in that sense, it's completely opposite from the REST template. It's reactive and declarative, which goes along with being asynchronous and non-blocking, because when you are declaring asynchronous operations, you want those to be declarative in the sense that you don't want them to kick off immediately. You want to be able to declare several of those together and then kick off and have them go off and do what they need to do. And reactive, it's exposing reactive types from Project Reactor, Flux and Mono, and we're going to see that in a moment. Part of my goal here is to actually get you exposed to that as well, and to get a sense. How many of you have experimented with Reactor? Okay, quite a few hands. RxJava, perhaps? Okay, also quite a few hands. Okay. How many of you think that you are sort of intermediate level at least, or beyond intermediate level? Okay, a couple of hands. Who thinks it's easy? Okay, no hands. Who thinks it's hard? Okay, I'm in that camp as well. I started from that, and after working with it for a while, I can tell you that there is light at the end of the tunnel. It's very steep in the beginning, and once you get to a sort of plateau, and then it doesn't bother you anymore. At least that's my experience, and I've talked to many people sharing the same. The last thing I'm going to say about the WebClient and out-of-the-box features is streaming. So the whole async non-blocking design and reactive is a very good natural fit for streaming because we're processing data that comes from the network in bits and pieces, and we already have to do things in that way, which makes it very kind of a natural step from there to turn that into, decode that into objects and to provide that in a streaming fashion, because the APIs we expose, they already behave in this way. Okay, so let's take a look at this with some code. Okay, so the first thing I'm going to show you is a kind of client application. It's not running on a server. I'm just going to run it here by itself. And it is using the REST template. So that's the original client for HTTP access that we have in the Spring framework. And the only thing I will show you here is that I'm setting up a base URL, and that's going to another application that I have locally, which is going to simulate a delay. You can see that parameter there. I'm telling it to delay each request for 2 seconds because I want to simulate some network delay. And if you haven't seen this, by the way, on the REST template, there's a URI template handler method, so I can configure how URI templates get expanded, and I can, for example, provide a base URL. And then the rest of it is pretty straightforward. I have a for loop, and I'm going to make 3 calls to obtain a person information from the REST template, and each one is going to be delayed by 2 seconds. So let's go ahead and run that. Okay, so first one takes 2 seconds, second one takes 2 seconds, and then the third one as well. And the total might be a little hard to see in the back. The total is 6 seconds, over 6 seconds, because each one takes 3 seconds. So obviously, this is not a big issue depending on what you're trying to do, but you can imagine that in modern day applications, we have to do more and more of that. And this is only the simplest possible example in a for loop. You might have to do things in a more kind of coordinated fashion where you make one call and then you take the result, then you make another call, or maybe you want to make 2 in parallel. So when we say the REST template is easy, and I'll come back to this question, it all kind of depends on what you're trying to do. It's not that the REST template became less easy over time, it's that the things that we do are quite different. Okay, so let's now take a look at using the web client. And I know Josh and others are really good at typing on stage, which I'm not. So I'm going to copy and paste. Okay. Wow, I do type fast. So we have a new version here. Oh, copied the wrong one. How about that? That never happens, right? Okay, no, that's better. Importing the web client, so that's a good sign. So this time, I'm going to create the web client, and it's going to the same URL, and that you can see I'm providing a base URL as I create the web client. And then I'm going to go in a for loop. And you can see here that the API is a little bit more, it's kind of different. All along the way, I can get suggestions. So when I first start out, I get the HTTP methods. Then I can specify a URI, most likely, but I can go straight to other things if I want to go with the base URL. And then after that, I'm going to call retrieve or exchange. We're going to talk about the difference, but retrieve is sort of the simplest option. And then I'm going to specify how I want to decode the response. And in this case, I'm going to turn it into a mono. Mono versus flux is a single value versus multiple values. And I'm going to turn that into a person. And let's go ahead and run this. Wow, 300 milliseconds. Wait a minute, something is wrong here. This can't be that fast. Anybody see the problem? Something in the base URL. Any other takes?
You're not blocking at the end.
I'm not blocking at the end. OK, we're getting close. Yeah. Any others? Not doing anything with the person. So do we even have a person? Let's take a look. Let's try and turn this into a local variable.
You're not subscribing.
Sorry?
You're not subscribing.
I'm not subscribing. There you go. Bingo. So that's the answer right there. So this whole thing is deferred. It's asynchronous, but it also doesn't kick off until I do something, until I subscribe. And you can see that I get a mono, and you can think of the mono as a promise of something I'm going to get. But it's not going to go and try to get it until I actually explicitly subscribe or ask for that to be obtained. So let's give that a try. and subscribe. Okay, so let's run that. Okay, 423 milliseconds. Great, still very good, but that's not the, I don't think we are successful here because it seems like we got farther. We actually fired the requests, but subscribe itself does not sit and wait. It does not block. So we simply kicked off, and then we took 200 more milliseconds, and it looks like something started to happen, but we actually did not do anything. So what we're going to do instead is we're going to remove the subscribe. And of course, we could, somebody mentioned, we could block. And we could do that. And that should do it. But this kind of defeats the purpose of being asynchronous and non-blocking in the first place, right? This is back to what the REST template does. And this is where I said it's asynchronous and non-blocking out of the box, but you can turn it into asynchronous blocking if you want. But this isn't really the way to do it because you want to defer and you want to make the most of the concurrency model here. So what we're going to do instead is we're going to think about turning this into monos, and then we're going to collect these monos, and then we want to kind of wait for all of them to complete and do something with that. So I'm actually going to use the Stream API to make this, get rid of this loop. So we're going to iterate over 3, and we're going to do a map of that index, and then I'm going to take this code down here. Since we have enough space, let's do that. And then we're going to collect all of this into a list. And what we've got now is a list of monos. And now we've got all the monos together. And we can start using some of these reactor operators. And this is where the power comes of all this, what's available to us. So we can say collect, but of course that's not a very good variable name. Let's say all our person monos. That's better. And of course, now we're declaring that we want to wait for when all of these are complete, but we still need to subscribe. In this case, we're going to, I'm just going to do a block, and let's go ahead and run it. So you'll see they all kick off immediately, right, because we're starting them off, and they're running in parallel, in 3 concurrently, that is. And then we get back the result, and we get a total of 2.9 milliseconds. So roughly 2 seconds, but a little bit more, not quite 2 seconds, but that's pretty much the time it takes to execute one of these, and because they were executed concurrently. But if you pay attention, and this is actually, I'm also showing you some 5.1 goodness here with the logging. One of the challenges here, and first of all, you will see that if you look at the threads, we can only see 3 different threads here. One is the main thread where we kicked off. And then we see 2 reactor netty threads. One is number 6, one is number 8. So we're not necessarily using as many threads in order to process 3 different calls concurrently. And that's the non-blocking concurrency model that I'm talking about. In fact, Reactor Netty out of the box runs with only 4 threads, which depends on how many cores you have on your machine. But the point is that as I need more concurrency, it's not going to use more threads. That's the blocking style. If you block, you need a thread to absorb that blocking. But here, what it actually does is it relies on callbacks under the covers, where it fires off these HTTP calls in the beginning, and then it waits for the result to come back, and then it deals with the result, but it doesn't need as many threads to do that, right? It can go in a sort of an event loop fashion. And we can correlate, and you can see that, for example, this here correlates with those 2 below. The response came, and they came in different, whatever order they came back. And then the total was, they were executed concurrently. One question here?
Yeah, sorry, I don't mean to or I apologize for interrupting. If you created another web client up at the top, would it by default use the same event loop as the other one, or would it create a new one?
Okay, so just for those in the back, the question is if we created another web client at the top, would that create a different event loop and would it use different resources? That's a great question. No, in fact, out of the box, by default, with React and Netty, the behavior is that it participates in globally defined resources, which you may or may not like this model, but it's safe in terms of the idea is that there's only one event loop. You don't really want more. The whole idea of non-blocking model is you don't want more threads. So by default, it will do that, but in 5.1, and I believe we backported it to 5.0, there is a possibility to create the web client with explicitly given resources, and then you can share those resources, kind of the more traditional style of passing around the resources. So that's also possible. Okay, so we saw this. One more thing that we're going to do here. Let's do this. So right now, over here, I'm using it's kind of split up the processing in two. Let me make this a little bigger. First of all, I'm using the Java 8 Stream API in order to collect this list of monos, and then I'm using mono.when. So let's use all Reactor facilities for the same, because that's going to help us to make a single chain. And now from here, we can repeat. Now, one thing which is tricky that I want to point out is that here we have a map operation, and the map is going to execute this here. But what was our experience in the beginning when we just try to run that? It doesn't do anything, right? Something needs to subscribe to it. So if we simply use a map operation, we're turning the index into a mono, but that mono isn't going to be triggered automatically. So when we work with Reactor, whenever we want to make a nested asynchronous call, which itself returns a mono or a flux, we're going to use flatmap. And flatmap is actually going to subscribe to the mono, and it's going to produce a, if you look at the return value of this, that's a flux of persons. So it took a bunch of monos and turned them into a single flux of persons, which is exactly what we want here, right? So that's where this flat map nesting, that's what it brings us versus a simple map, which would give us a flux of mono of persons. So that's why we want to deal with that nesting. And now that we have this, we actually don't even need the mono when, because we can go here and we can just say block for the last one. Of course, this is no longer a flux of persons. Or we can say something like do on next, and then we can take a look at each person, and we can do something with that person. Basically, we're getting a flux of those things. Or we can just say dot then, which gives us a mono void. So dot then basically says when all of this is done, tell me when that's complete. So I can just do that, and then dot block. But really, it's the same thing as saying block last. Just block for the last one. Wait for all of them until the end. So let's go ahead and try this also. OK, and that came back. OK. One more thing I wanted to mention here with the web client is the retrieve operation. So the retrieve operation gives us kind of a straight path to the body of the response. So we can just say body to mono. But if I wanted to, I could also say dot exchange. Let me kind of nest this a little bit. Dot exchange. And what this gives me is actually, it gives me access to the response before the body has been read. So now I can say response.status code. What's the status code? I can say response.headers. What are the headers? But if I want to deal with the body, then I have to specify how I want to decode the body. And that's an asynchronous operation, right? I'm going to have to wait for the data to come and then decode. And that's why I'm using a flat map. So I can return here and I can say, let's turn that into a person. And type it in just so I can remove it. OK, here we go. So this gives us exactly the same thing, but you can see here I have to do an extra flat map, and that's a more advanced operation. If you want to kind of peek into the status code, if you want to look into the headers before you decide how to deal with the body. But for the most part, usually you can just use retrieve and then deal with it that way. One of the other things you can do with the response here, you can say to entity, and you can say person.class. So that will give you a response entity, just like with the REST template, if you wanted to get the body or if you wanted to get the whole response entity. OK, one more thing to show you here. And I'm going to copy that in the interest of time. So one of the other things that's interesting to do is imagine that for each one of these HTTP calls that we make, we want to make a nested HTTP call, which means that we want to make another one, and then we want to combine the results. So those are the kinds of things that you might end up, kind of orchestrating. And I just want to show you how beautifully easy it is to declare such things. And to point out the fact that you're not dealing with threads, and yet the whole thing is fully concurrent and does it in the most efficient manner possible. So here, the beginning is very similar to what we had before. We're going to make a call, or 3 calls for a person. Then we're going to decode the data. And then we're using flat map again because we're nesting to another asynchronous operation. So when we get this person here, when one of these is ready, then we're going to make one more call, this time to obtain a hobby for that person. And then we're going to turn that into a hobby class and then block for the last thing. So let's go ahead and run that. And this time we're going to see the first 3 calls go out. And then as soon as they come back, the second 3 calls go out. So it's all running kind of concurrently. As soon as the data becomes available, it fires the other calls. And the whole thing completed in 4.7 seconds. But this is, if you think about it, if you do this sequentially, it would require 6 times 2 seconds, 12 seconds. So we're saving quite a bit of time by doing this as concurrently as possible. Cool, right? Yeah, definitely. OK, then one more thing here. Is this, which is the streaming case. So I mentioned that this is a natural fit, and certainly you can see here how when we're saying body to mono, we could just as well say body to flux. We're going to, this is actually an SSE stream, and we're going to obtain the first 4. And then, let's see what's happening here. 404, not found. OK, so it's actually time to look at the backend app. OK, so I have 2 apps. One is the main app, and then the second one is called remote services. So we're kind of simulating some sort of backend remote services. Originally, I was using http-bin.org. Anybody heard of http-bin.org? Seen it? And then when I was doing my own tests, and I'm simulating delays, it was delaying much more. And I said, OK, what's wrong with my web client? And then I look, and finally I realized it's actually the website is taking longer. So I decided to write my own kind of backend here. Now, this is a WebFlux application. It's not relevant to the presentation, but I'm going to show you what's here. Anyway, this is using the Java DSL for the functional endpoints. And you can see here, I have URLs for persons, a stream. So persons, events, I think that's the problem. Oh yeah, it looks like I renamed it. Okay, let's run this. Okay, and there's one coming every 2 seconds. And I could leave it to run all day. It can stream for a long time. But in this case, I'm taking only the first 4. And I wanted to show you here the filter. So for all of these requests, I have a filter applied. And that filter is going to look for the delay parameter. And then if there is a delay, I'm going to use mono.delay and then flat map and then delegate to the chain. So you can see how easy it becomes to kind of simulate these sort of things. Okay. Okay, so back to the slides. A good question here is, isn't the REST template easier to use? And that's kind of a common question. And of course, when we come from having used it for 10 years, and we think of it as being simple, well, it's really the things that we do that have changed. If you find yourself in a situation like this where you have to make multiple calls, if you want to think about how to make that concurrent, how to make that efficient, and then on top of that, to actually think about efficient execution, so you can scale, well, that becomes a very different game, and it becomes very difficult to think about, dealing with threads and executors. Then in that case, by all means, it's not easier and it's not simpler. So it really depends on what you're doing. Personally, my feeling is, and once you get over the barrier of learning about Flux and Mono, which I think in the context of WebClient is a lot easier, the other thing you will come across is debugging experience. Obviously, we're doing things concurrently, but when we're trying to figure out what's going on, obviously now we're dealing with a small number of threads dealing with a large number of things. And when you want to debug the kinds of stack traces you see, you cannot no longer use the stack trace to understand where exactly the code. And Reactor has features for that. If you go into the Reactor documentation, there's a section about how you can enable better stack traces, which has a certain cost associated with it. But if you're debugging, that can help you a lot. But the whole experience changes, and sometimes the initial reaction tends to be the web client is more difficult. But that's a case of killing the messenger, because don't shoot the messenger, because really now you're in an asynchronous environment, and the problem is not the web client. The problem is that you are trying to do things asynchronously and concurrently for good reason. And even if you're using executors, you wouldn't be in a better place. Your debugging experience would still not be very easy. So it kind of comes with the territory. Will the REST template be deprecated? So we contemplated doing that in 5.1. We had a conversation about that. And at the end, we decided not to deprecate it just yet because there aren't any concrete drivers at this time. Ultimately, in the long run, we don't want to maintain 2 parallel solutions. In fact, as we have to add new features for HTTP client access, we're not going to do that on the REST template side because we don't want to develop in parallel, and the web client is a better place for new features in any case. So if we talk about the JDK 11 HTTP client being supported as one of the options, that's only going to come to the web client. If we talk about requests like streaming, we're not going to try and add that to the REST template because, as you can see, there's just so many reasons why the web client is a better place to be. So while it's not deprecated, we have mentioned in the documentation that it's something that we are going to do at some point, but at this time we don't have a strong enough driver, and there's no harm. If you're using it, there's no harm in continuing to use it. It isn't bad all of a sudden, but please take the time to spend a little bit of learning around the web client and use it where it's appropriate. Speaking of that, if we now go to the server side, it all begins to make a lot more sense. In Spring MVC, originally, we decided that we're going to keep reactive support out of Spring MVC and strictly in WebFlux to make sure things are not confusing. However, as we got closer to 5.0, we realized that by all means, we actually should have support in Spring MVC. And the reason is because the whole idea with Spring MVC anyway is that if you do something in the controller, the framework should adapt, those flexible controller method signatures. So what if you use the web client? Now you've got a mono or you've got a flux. And the most natural thing to do is to return it from the controller method. So we should be able to deal with that because you're likely going to do that. In fact, it is a good idea to do. And for this reason, we have support from 5.0. So it's been there for a year. But it's just something that we haven't pointed out as much, and I think a lot of people don't know about it. But you can return Flux, Mono. You can return RX Java types from a controller method. And we are going to deal with that. Spring MVC is going to handle that. It's going to use the same mechanism as the deferred result, for those who are familiar in Spring MVC, decouple from the servlet container thread, and then deal with the Flux and Mono. So it's built on the Servlet 3.0 async support. Under the covers, this is what we do. If you give a mono, that directly translates into a deferred result. We're going to wait for the mono, subscribe to it, and then set the deferred result. So if you're familiar, if you're using deferred result, it's basically something that you would understand or it would be familiar. If you return a flux can have any number of items. We don't know how many items. Will it be a finite collection? Will it be an infinite stream? So for that, we actually rely on the media type in order to understand, is this going to be a stream or is this going to be a finite collection, most likely? If it is application JSON, for example, we consider that to be a finite collection. You're not going to be sending endless number of those. So we aggregate them into a list. And then we basically treat it as a deferred result of a list. If the situation is streaming, however, say, for example, we're talking about event stream, server sent events. There's also another one we support called application stream JSON. Then in that case, we have a clear indication that there's going to be a potentially infinite number of events. Well, infinite is a strong word, but it could be, we don't know when it's going to end. It might be a while, and there may be some time between the items. So instead, we're going to basically write that to the response using response body emitter. And we're actually going to apply back pressure against that, which means that if you give us a flux, we're going to keep requesting one at a time and applying back pressure to whatever the source of that is. So this works pretty well with the web client, and you can make these kinds of concise declarations, orchestrate remote calls from the server side. You're not dealing with threads anywhere. And on top of that, you get efficient scale and execution, which is important on the server side, because if you think about it, it's no longer just using one web client. You're sharing that. If you have 100 requests coming at your server, each one is using the web client, well, that's 100 automatically and 100 concurrent remote calls that you're making. So you're automatically much more concurrent scenario when you're on the server side. And of course, with the web client, you automatically get the efficient scale under load, and it's using only 4 threads, again, depending on the core. And the reactive handling is not just the web client. So we have Spring Data repositories. As you know, Spring Data K, it's got MongoDB support, it's got Couchbase, Apache Cassandra, and Redis out of the box. And we have some more exciting news in that area coming tomorrow. So be sure to look for that in the keynote tomorrow morning. And there's also talks. So if you look at the schedule, it's actually there. It's not a complete secret. The Cloud Foundry Java client is built on a reactive foundation. It returns reactor types. So there's lots of various libraries by now that are using reactive streams and maybe RxJava, maybe Reactor. All of these thanks to reactive streams, you can mesh together and you can compose pipelines of things, declare asynchronous things to do, and then just return back to the controller. So let's take a quick look at that also. I mean, it's more or less what we've seen so far, but in this case, it's on the server side. So I have a controller, and I have a web client. And in this case, I'm injecting a web client builder, which Spring Boot gives me. And I should show you the Maven POM for that briefly. So one of the things when you want to use the web client, and the web client is in the WebFlux jar, you're going to have both the starter, the web starter, which gives you Tomcat and Spring MVC by default, and you're also going to add the WebFlux starter. And when Spring Boot sees both of these in the same POM, it knows, okay, so you probably want to run Spring MVC and then use the web client or some other client-side facilities from the WebFlux jar. Okay, so now if I start this application, I want to show you here. So this is running. This is running with Tomcat. Okay. Okay, maybe we'll see that in a moment. And what this application does is I've got the web client builder injected, and I'm giving it a base URL. So I'm going to be contacting that backend remote service from my controller. And then I also have an account repository, which in this case is a Mongo repository. And you can see that on startup, I'm actually inserting a number of different accounts with a score, associated score. And then this is the implementation for a person. You can see it's simply making a remote call. It gives me back a mono, and then I'm going to give that mono back to the controller as a return value from the controller method. Or I'm going to return a flux of persons. So let's go ahead and run something here. And this is the main app, so 8080, and let's go to person.1. Takes 2 seconds, and then it comes back with the data. And you can see the actual log. So that's the dispatcher servlet. So yes, this is Spring MVC. And we are going to handle this request. And you can see here from the Tomcat thread, it's going to initiate the HTTP GET. And then it's saying starting an asynchronous request, and I'm exiting, but the response remains open because I know that there's more stuff that needs to be done for that mono to complete. And then at some point, 2 seconds later, on a React and Netty thread, we're getting back the response from the remote service. We're decoding a person. Now we've got the result, and we're going to do a dispatch back into the container. So that's the deferred result. If you know the way that the deferred result works is do one more dispatch into the servlet container, and then we're going to write that to the response. So again, this is what you would see with use of deferred result, which we've had for a long time, except now you can do that also with reactive types. So let's give this a try also with a flux. Okay, so now we got application JSON, and that's a JSON array. And you can see here similar output, but in this case, we are decoding individually all the results, and we're turning that into a list, and then we're dispatching back into the servlet container, and then we're writing that JSON array or that list of person objects. Now, we can also do a stream. So that would be person events. Okay, so that's SSE, and we're getting the data back. And you can see here how we're decoding. Okay, so this is streaming from the server side. It's getting a stream from the remote service, and then that flux is being written back to the response of the client. So those kinds of things you can see become possible. And this here is a Tomcat error, which unfortunately not much I can do about, because the connection went away essentially because I killed it from the client side. One more thing to show you here is making a kind of a more concatenated sort of a orchestration, a slightly more advanced thing to do. So I'm going to use the account repository. That's the Mongo account repository. And I can show you here that this is extending the reactive CRUD repository for Mongo from Spring Data. And then I'm going to make a call to find all, and I'm going to sort them by their score. I'm going to take the first 5. And then I'm going to flat map, but I want to keep that sequential. So I'm going to make nested asynchronous calls. And I'm going to make one call to get the person, another one to get the person hobby, and then I'm going to zip the results together and return that back to the response. Right? So we want that executed in the most efficient way possible. But you can see, instead of dealing with threads, I'm actually declaring which depends on which, and which can be concurrent, like these two can be concurrent. And I let it deal with the rest. So let's do, let's see, accounts. And I'm going to give you a link to the source code. So there's a repository for this. You don't need to. I'll give it to you at the end of this presentation. So you can see that this came back pretty quickly. Let's take a look at the output. Okay. Exiting, response remains open, and it's going to make a total of, I guess we have 5 different persons, and then we're going to make 2 HTTP calls for each. That's 10 calls, and it pretty much fires all of them together and then waits for the results. Again, the cost of making extra calls is a lot lower because we make those calls, and then we're not holding any threads. We're just waiting whenever they come back, and then we deal with the results. Okay. Okay, so let's talk a little bit about best practices. So all of this looks nice and accessible. Of course, there's some learning involved with using Flux and Mono, but one way I like to think of it is kind of like the Java 8 Stream API. If you've been through the process of taking a for loop and turning it into a stream, it's sort of a similar type of thing, except here we're also dealing with asynchronous non-blocking things, and obviously the stack traces are not going to be as helpful. But one of the common things I see is, because we're so used to the synchronous blocking style of doing things, that as we begin to experiment with this, one of the things to expect is you're going to find yourself in a place where, let's say you're in the middle of this kind of processing chain, and then you have to call something, but you've got a mono, so it's like you want to do a dot block so you can get the data, because that thing expects the data and not the mono. So when you start to deal with this kind of mix of blocking and non-blocking, asynchronous and synchronous APIs, it becomes very tempting to try and do these kinds of things. But the thing to learn over time as you go on this journey of learning reactive and using these declarative functional style APIs is that you want to defer. You don't want to block, but you want to integrate into the processing chain. So I showed you, for example, using flat map along the way. So you got a mono, and you need to do something. OK, you need to flat map, and then you can deal with a callback that gives you the value, and then you can call the thing, and that can integrate into the main processing pipeline. So you're basically looking at deferring as much as possible. In fact, if you look to the kind of things we do here is we are always returning the flux or mono from the controller method. If you're doing something asynchronous, but you're returning not flux or mono, you're returning the actual value, you probably had to block somewhere along the way, and you really don't want to do that. It's sort of like taking a flight, and when you take a flight, you basically don't want to, you want to stay in flight, right? You don't want to land because you're going to lose time for connections, and you want to get there. And I think the same analogy sort of works here. When you start composing something, so here you're getting accounts from a repository, you got a flux. You don't want to block for these and then continue. You want to continue to compose. So I'm going to use flat map, and then that tells me, OK, when you have an account, what do you want to do? So I'm going to use this lambda here to express what I want to do once there is an account, but that account isn't going to come until something subscribes to my flux. And again, the Stream API has this kind of deferred nature, so I don't think this is anything too radical here. So just like with using WebFlux, where you want to find applications to convert in full, so you don't want to have too much mixing of blocking and non-blocking, I think the same is true in Spring MVC as well. You want to find kind of vertical slices, controller methods, or controllers that you can convert so you're not doing partially blocking, partially non-blocking. Try to start with something that you can convert the whole thing to non-blocking. And then don't try to do things like write a bunch of non-blocking code and then put it behind a synchronous API, because that's what you'd like to expose. It's easy to go from asynchronous to synchronous, right? You just do a dot block and you're there. If that's what you want to do, you can do it. But it's not possible to go the other way around. Once you give a synchronous API, that's it. You're limited with that synchronous API and whoever is using yours, because you're concerned about the complexity you're exposing people consuming that API. But at the same time, you're giving them less choice. So if they actually want to make use of this asynchronous nature, you're not giving them that option. So it's always better to make the API asynchronous and non-blocking, and then if you have to, provide a synchronous layer on top. But try and encourage kind of keeping that flight going instead of landing. So in the end, you want to compose a single request handling chain, deferred request handling chain. Once again, I mean, this is the example here. It's all interconnected at the end of the day, right? First, we have to get the accounts. Then for each account, we want to make calls for a person and for a hobby. Then we want to zip that. And the whole thing is being flattened into a single stream of maps of person and hobby data. So that's where you want to end up. You want to compose that kind of single connected chain that can be subscribed to and triggered, and then the whole processing continues. Within a controller method especially, you don't want to ever have to use block or subscribe anywhere. I'm returning the flux to Spring MVC, and Spring MVC will do it. So again, we're trying to defer as much as possible having to block or subscribe. And then finally, I'm just going to mention end-to-end testing for HTTP, because this is relevant to Spring MVC. So we added the web test client in Spring Frame 5, and that's a very thin layer over the web client, which means that the API is very similar. The benefits are very similar. All of what you saw here is a similar experience. But once you get the data at the end, from there, you have a verification API, which you will find similar to mock MVC, but without the static imports. It's, again, a functional Fluent API. Now, in Spring MVC, this was built specifically for WebFlux, so you can test WebFlux controllers, WebFlux endpoints. But it can also be used because it is a client, and that's the difference with mock MVC. It actually sits as a client making HTTP calls. You can use it for end-to-end integration testing of any backend. It can be Spring WebFlux, or it can be Spring MVC, or it can be Python. It can be anything that you want to test. And you can do streaming scenarios quite easily as well. And I did write some tests for this, so I'm going to show you that. So this is what it looks like. You will find that it looks a lot like using the WebClient, but once you perform an exchange from there, it's all about verifying what happened. And we actually do block for the exchange to complete, because in a testing scenario, you don't want the test to end before the call is done. Typically, you want to test the thing. So we're going to wait for the result, and then we can say, OK, what's the status? What's the header? However, we're not blocking for the body. So you still have the opportunity to express how the body should be decoded. So among the options here is I can turn it into a person. And that's a big advantage versus mock MVC, because this is an actual client that we can decode. We can use things like JSON path. So we can say, let's verify like this. Or we can deal with streams. So in this case, you can see here that we have, we're making a SSE request, and then we're going to get the first 3 of those for the test. And then we're going to use the Reactor core step verifier, which allows us to deal with streams of flux and mono, and then to kind of verify the values individually one by one. So that's kind of a nice thing if you have to test, do integration testing or SSE. And that's pretty much all I wanted to cover. We have a few minutes left. I wanted to provide a link to the source code repository, so you can get that right away. There is that typo that I had to correct. So I'll fix that after the presentation. But if the SSE client example doesn't work, it's because the URL is wrong. So just compare to the back end. There is an article on InfoQ that I wrote not long ago, if you'd like to check that out, on Servlet and reactive stacks. It kind of takes the perspective of Servlet developer, Spring MVC, kind of where we come from and what all of this means. And also the Spring Framework reference has been majorly updated with regards to the web content. So if you actually now, let me go there for a second. So you'll see in the reference that we have, come on. That we have 2 different sections, one for Web Servlet and one for Web Reactive. And if I go into, say, the Web Servlet, for all of the information here, you will also find a link to the same in WebFlux. And the reason why I show it here is because in order to be able to do that, we had to majorly rewrite the Spring MVC content to make sure it corresponds and it's comparable to the one in WebFlux, so you can see how does it work in one, how does it work in the other. And of course, when you do that, you run into documentation that was written 1 year, 5 years, 10 years ago in some cases, and you want to rewrite it. And so that's what ended up happening. So anyway, the web content has been majorly updated, so please take a look. Keep that in mind, and then if you have suggestions for improvement, let us know. We take that quite seriously, and we make the changes right away. And also the Reactor documentation, I would say, is pretty good. There isn't much on Reactor Native, but the Reactor documentation is actually pretty good, and you can learn quite a bit from that. So if you want to explore Reactive, that's a good place to start. And with that, I'm just going to point out 3 talks. There's lots of reactive talks, good ones. So by all means, look at the entire schedule. But I picked a few which I thought might be useful for learning if you're coming from the point of view of trying to figure out reactive and trying to understand how it relates. I think these talks are something that you will probably benefit from. And that's pretty much everything. Thank you.